All right, let me talk about factors, matrices, and data frames. So these are slightly more complicated structures in R. So we talked about vectors, atomic vectors, and lists. A factor is used to represent categorical variables or categorical values. Internally, a factor is just an integer vector. Okay, it's just an integer vector, but we have attributes, and the attributes are going to be basically the levels, and then the class is going to be that it's a factor. And so here I have a character vector, okay, with the characters M, F, F, X, M, and F. And so this is a character vector, and I can turn this into a factor by using this function factor, okay? Factor on this gender character vector. And now I get, when I ask for this gender factor, I get the values M, F, F, X, M, F, okay? And the levels in, it also prints out something called levels, which lets us know that this is a factor. One thing, is when you print out a character vector, normally you see little quotes around the elements like this, okay? But here, the default printing of a factor is that it doesn't put little quote marks around it. Here we ask, what are the levels of this thing? This is just basically information that's stored in the attributes list, and this will be F, M, and X. And when you say type of, okay, the type of is an integer. And what's happening is that internally, the vector is going to say the integer 2, the integer 1, 1, 3, 2, and 1. And when R prints it out, it says, okay, I see the integer 2. We're going to get the second value from the factor, which is an M. It sees the values 1 and 1, and it says we're going to get the first value, and those correspond to F. It sees the integer value 3, that corresponds to X, and that's what is happening. Okay, when you can see internally what that is by calling as.integer on that factor. Okay, and again, here we get 2, 1, 1, 3, 2, 1. All right, and again, when you ask for the attributes, you have the levels, F, M, and X, and so the 2 corresponds to the M, the 1s correspond to the F, the 3 corresponds to X. When you ask R to create a factor out of a character vector like this, R looks over and sees all of the unique values. The unique values get put into levels, and by default, R puts those levels in alphabetical order. So F gets first position because F comes before M in the alphabet, and M comes before the letter X in the alphabet. So we get F, M, and X here. And so that's what we have, the levels and the factor. And that's how it's stored internally. Okay. Now, there's a few things that could go wrong when you're dealing with factors, okay? If you have a vector of numbers and those get turned into factors, then some weird things could happen. So if I say, hey, 0, 1, 10, and 5, and I say make a factor out of that, all right, then this X factor, we get 0, 1, 10, and 5, and we see the level 0, 1, 5, and 10. And if you ask for, hey, what's the mean of this? It's going to give you an NA, right? It's going to say, hey, I can't take the mean of this thing. Because, again, factors are intended to be treated as categorical variables. So, even though it looks like numbers, they're actually categorical variables. It'd be kind of like asking, hey, what's your area code? Your phone number area code. It looks like a number, but it's actually a categorical variable. It just kind of gives you like a geographic category, because area codes are generally assigned by geography. And it wouldn't really make sense to say, hey, what is the average area code of a group of friends? Okay, so one person's area code might be 818 and someone else's area code might be 310 and things like that. It doesn't really make sense to take the mean of those of the value 818 and 310. Okay, that doesn't really make sense. And in the same way, it doesn't make sense to take the mean of a categorical variable. Now, if you wanted to, you can kind of force it, and you can say as numeric, okay, as numeric on the factor, and then take the mean, right? And if you think about it, 0, 1, 10, and 5, that adds up to 16, and the mean should be 4, but when you say, hey, mean on this, we get a 2.5. What's happening? Well, when you call as numeric on this thing, it gives us back 1, 2, 4, and 3. Remember, internally, it took these values 0, 1, 10, and 5 and converted them into these levels, 0, 1, 5, 10. And so the 0 is the first value, 1 is the second value, 5 is the third value, and 10 is the fourth value. And so, those values are 1, 2, 4, and 3. And all it's doing is it's taking the mean of 1, 2, 4, and 3, which is going to be 2.5. Okay, but again, x underscore factor is a factor, and it doesn't quite make sense. Now, if you did want to take the mean of 0, 1, 10, and 5, what you can do is you can convert that factor into character, and then you take those characters, convert them into numeric values, and then you take that and you take the mean. So here we're going to turn 0, 1, 10, and 5 into a character vector, which will be quote 0, quote 1, quote 10, quote 5. And then we turn those into numeric values, which will give us 0, 1, 10, and 5. And then we can take the mean, which will give us 4. Okay. Other things about factors is if you try to assign values to a factor and it's something that's not in the list of levels. So in the gender factor, the list of levels that are allowed are F, M, and X. And if you try to put something like male here, it's going to induce an NA. And so that's what's going to happen. You have to kind of put in a value that actually makes sense or is allowed. Okay, matrices. A matrix in R is basically an atomic vector, and that comes with a dimension attribute. A vector for the dimension attribute is a vector for the number of rows and columns. So here I'm going to create an atomic vector of integers 1 through 10. That's going to be M. And if I ask, hey, what's the class on this? This is an integer vector. Now what I can do is I can use ATTR to set the attribute, and I'm going to set the dimension attribute to 2, 5. Basically tells R I want 2 rows, 5 columns. And so now it turns this atomic vector into a 2-dimensional data structure. And it fills it out column-wise. So it goes 1, down the first column 1, 2, then the next column 3, 4, then the next column 5, 6, then 7, 8, and then finally 9, 10. And now when you ask what are the attributes on M, it will say you have a dimension attribute, which is the thing that we just created, and it's got the values 2, and 5 in there. And now if you ask what is the class of this thing, where M used to be integer, now that R sees there's a dimension attribute, it's going to say, hey, this is a matrix, which is kind of a subclass of an array. Now, what you can do is you can get rid of that dimension attribute by just assigning null. Okay, basically null says, hey, get rid of that. It's going to get rid of the dimension attribute here. It's going to just kind of wipe that out. And now M is back to being an atomic vector, one-dimensional atomic vector. And if you ask what's the class on this, it's going to be integer. Arrays in R are basically atomic vectors, but now the dimension attribute has a length greater than 2. And so here I have a vector A with the integers 1 through 12. And here, as far as the dimension attribute, I'm going to assign a vector with the values 2, 3, 2. Okay, so that's basically 2 rows, 3 columns, and 2 levels or 2 layers or 2 sheets, however you want to think of it. And it fills it out first by across the rows, then through the columns, and then across the sheets. So we get 1, 2, 3, 4, 5, 6 in the first sheet, then the second sheet, 7, 8 down the first column, 9, 10 in the second column, and 11, 12 in the third column. And so we can do that. You create the value, and then and then you can assign the dimension attribute. Okay, you can also create an array using the function array, basically, and you would provide it with the values and then the dimensions there. Right. So those are 2D or 3D structures, matrices and arrays. And then we have another two-dimensional structure, but this is a data frame. Data frames allow different value types. So you can have one column that's floating point, another column with integers, or maybe these are also floating point, another column of floating point. You can have a column with character values, column of logical values, however you want it. Internally, a data frame is stored as a list, and the lists inside that the elements in that list are all going to be vectors that have the same length. So this data frame trees has a list of three things: a list for girth, a list for height, a list for volume, and each vector has a length of 31. So here you can see all of that thing. You can say, hey, what is the class of trees? It says it's a data.frame. What is the type of? Internally, it's stored as a list, okay? And then if you ask for the structure of that, basically it says it's a data frame, basically a list where we have three variables, three elements in it, in that list, and each one is a vector of length 31. And we can see it says numeric, 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 and these are the different values in there. Okay, if you call as.list on trees, you can see what we have. We have a vector for girth, and it's a length 31 vector. A vector for height, and it's a length 31 vector. Vector for volume, and again, length 31 vector there. And then if you ask what are the attributes, okay, the attributes, we have the names, column names, the class is data frame, and then the row names, the default row names are just the integers 1 through 31, but you could also assign different row names there. All right, that's that for this video.